Welcome back to my channel. So today I'm going to be solving leak code number 253, meeting rooms 2. So yeah, let's just get started. So given an array of meeting time intervals where intervals at I equals start sub I, end sub I, return the minimum number of conference rooms required. So if we have intervals 0 to 30, so we have one meeting from 0 to 30, we have another meeting from 5 to 10, we have another meeting from 15 to 20. In this case, we'll need two separate meeting rooms because this spans the whole time, and then these two, they don't overlap at all, so we can reuse the same meeting room for them. And then for 7 to 10, we have one meeting, and 2 to 4, we have one meeting. Then we can just reuse the room because these don't overlap at all. All right, and then here are the constraints down here. So yeah, let's just get started. So the idea is, if you're still a bit confused on what it's asking, is if all these meetings were to happen, like let's say we're at a business, we have all these meetings planned for today, how many conference rooms or meeting rooms are gonna be required for us to successfully conduct all these meetings that are planned? So if I can show, I'm gonna show on the whiteboard. First, I'm gonna show like I guess the regular approach of why it doesn't work out, and then I'm gonna show like an actual like a visual of what's going on, which I think will be really helpful. It took me a little bit to understand what this problem was asking, and like as I was reading through and like watching other videos, it just wasn't clicking in my head, so I had to find a way to like draw it out like a little kid to understand, and I think it was really helpful. So I hope it's helpful for you guys as well. All right. Anyways, so let's say we're gonna use this example that they gave us. We have these three meetings, and we need to figure out how many meeting rooms we need. So we have 0 to 30, and then 5 to 10, and then 15 to 20. Okay, so and we have 15 to 20. So what we can do, so these represent the times, so the intervals of the meetings. So we'll have some bar here. Oops, that was really bad. Okay, so let's say this represents our first meeting, 0 to 30. And we're going to assume these meetings are sorted so that the earliest one appears first, and then the next earliest one appears, and then the next earliest meeting appears. So yeah, just keep that in mind. So this is our first meeting, right? We know we already need one meeting room. We have one meeting, we're going to for surely need one meeting room. So now we go to the next one, which is a 5. And we say, okay, I have this meeting coming up. Where does it fall in here? So we'll say 5 to 10, there's another meeting. The question is here, are we gonna need another meeting room for this meeting, or can we reuse the meeting that we're using? Can we reuse the meeting room that we're using for this meeting? And the answer is, we're obviously gonna need another meeting room, but why is that? Because this meeting lies in the time where this meeting starts and ends, meaning it's between it. So there's no way you can use the same meeting room. You're gonna need your own meeting room. So hopefully that makes sense. You see that this meeting starts before this time ends. So obviously you can't use the same room. So okay, let's keep going. Let's check the next one. So 15 to 20. So let's say 15 to 20. 15 to 20. So let's move up. So let's go to the last meeting room the previous meeting that's before this meeting. So we see that our previous meeting is going to be between 5 and 10, right? Can we reuse the room that we're using for this meeting? Can we reuse that same room for this meeting? And the answer is yes. Well, why is that? Because this meeting starts after this meeting ends. So okay, we can reuse the room. It doesn't collide, it doesn't conflict, the times don't conflict, so there's no issue with reusing that. So we know that we needed one room for this, right? We needed one room for this meeting. And we now know that for this meeting here, we can reuse that same one room. So now how many rooms total will we need? Well, 1 plus 1, which equals 2. So you guys understand that. I guess that's pretty standard. And hopefully that kind of makes sense. So the pattern is we are checking, okay, if the meeting that we want to conduct, if it starts before or after what the ending time of the previous meeting. All right, so I hope you guys get that. I'm gonna do a little visual. So, um, oh wait, I'm gonna do another visual that might be easier for you to see. So we're gonna do that right now. Okay, so let's say, okay, this is gonna be okay. This is gonna be childish, but it's helpful. Trust me. So let's say like we're at Microsoft and there's a meeting being held and this is Bill Gates, right? He's holding a meeting. It's a really bad drawing, but so this is Bill and we say we're gonna use the same example by the way, this one. So we say, okay, Bill is in the middle of a meeting. He's holding a meeting from 0 p.m. I'll just call it p.m. So 0 p.m. to 30 p.m. Right? Bill's in a meeting. And let's say a lot of other people want to conduct meetings today and they want to find out if they need a new room or if they can reuse Bill's room because it's already set up for them. So let's draw those people. So here's me. I'll draw myself. So here's me. So Hawa. Wait, no, let me not. Yeah. So here's me. I'll say this is Hawa, right? And then there's going to be one more person. I'll just draw my brother. So this is Adam, right? So their meetings haven't started yet, but they're about to start looking around for rooms. So Hala said, so like my meeting is gonna be held from 5 p.m. to 10 p.m. Okay, I probably didn't need the p.m. I'm getting too into this story, but so 5 p.m. to 10 p.m. and Adam's meeting is from 15 p.m. to 20 p.m. Okay, and then let's say Bill right now he's in meeting room A, and we'll go from there. So now remember we're using the same example, so try to tie it back to what I just talked about earlier, but I'll explain it as I go. So first, how is obviously like my meeting is first, so I'm gonna go before Adam to look around for meetings so I can know when to set up. Like my meeting's about to start, I need to find a room. So I go this way. The first room I come upon is room A, Bill Gates' room, and I interrupt Bill, and I'm like, "Yo, Bill, sorry to interrupt. I'm looking for a meeting room." And I ask him, "Can I reuse your meeting room? Does your meeting end before mine starts?" I go to Bill, and I'm like, "My meeting starts at 5. Are you gonna be done by then? Is your meeting gonna be done by then?" And Bill gets super mad, like why are you interrupting my meeting? But he's like, no, my meeting ends at 30, so you obviously can't use my room. Go find another room, right? So I'm like, okay, because my meeting starts before Bill's meeting ends, I need to find my own room, right? So I go this way. I found there's no other meetings. There's just one open room. I'll call it room B, and this is where I will conduct my meeting. So I'll say, okay, Hawa has this room. Hawa, let's say I have this room from 5 p.m. to 10 p.m. Okay, awesome. So right now we have 2 meeting rooms. So now I'm gonna erase myself here. I'm just gonna erase myself here. So it's gonna get really messy, but try to follow along if you can. Okay, so now I have room B. Okay, so now Adam comes along, and Adam's like, okay, my meeting's about to start at 15 and 10 minutes. I need to find an available room. Adam goes to Bill. Remember, Bill's meeting started the earliest. That's why we're checking, because we're like, okay, if his meeting starts the earliest, maybe it will end the earliest. Let's just check. So Adam goes, he goes to Bill's room. Remember, Adam's meeting starts at 15 p.m. So Adam goes to Bill's room, and he's like, yo, Bill, I need a room. Does your meeting end before my meeting starts? My meeting starts at 15. Does your meeting end before or on 15? And Bill says, oh my God, like Bill's super mad at this point. He's like, do I not teach you Microsoft employees anything? Okay, this is like, I'm getting too engrossed in this story. Anyways, so Bill's like, do I not teach you guys anything? Why are you interrupting my meeting? But Bill's like, okay, but no, my meeting ends at 30 and yours starts at 15. My meeting ends, your Adam, your meeting starts before mine ends, so you can't use my room. Go find another room. So Adam's like, okay, bet. So Adam now, he comes to my room, my meeting room, and he's like, yo, Hawa, he's like, I need a meeting room. It starts in like 10 minutes. How does your meeting end before mine starts so that I can reuse your room because everything will already be set up for me. Why would I find a new room? So Hal was like, yeah, my meeting ends before yours starts. My meeting before yours starts. So my meeting ends at 10, yours starts at 15. So I'll be out of your way and you'll have 5 minutes to come in and get set up. So Adam's like, okay, bet. I can reuse your room, Hawa, once you're done with your meeting. So now Adam is in line. Okay, so now I'm gonna erase these. So we know that Adam can reuse my room once I'm done because his meeting. So you need to pay attention that I keep repeating the same thing. His meeting starts. No, my meeting ends before Adam's meeting starts. Or you can say his meeting starts after my meeting ends. But I'm gonna keep the same way so I don't get confused. Okay? So now here is Hawa's room. Hawa's in her meeting. Bill's in his meeting. And now Adam is in line to use room B. And Hawa is in room B. I'm in room B. I'm about to finish up my meeting. Adam's meeting starts at 15 and his meeting ends at 20. So now me and Adam have reused the same room B. Bill has used room A. How many rooms did we use? We used 2 meeting rooms, so 2 rooms. But we had 3 meetings. I mean, that's not like a big factor here. Okay, that was really bad. That's not a huge factor here, but let's just say so we had 3 meetings and we used only 2 rooms because we were able to reuse room B because my meeting, my meetings ended before Adam started, so I was able to get out of there and he was able to come in and set everything up before his meeting starts. And yay. So that's literally it. So there's more to this that we have to pay attention to. This is when we're going to start paying attention to our room numbers or our room letters, which room we're actually in. And I'm gonna come back to this once we get to that part in the code, so it will make more sense. So remember this logic, okay? So now we're gonna go to our code and we're just gonna start. So the first thing we're gonna check, we're gonna say, okay, if there are literally no meetings scheduled for today, then we'll just need 0 meeting rooms, so we'll just return 0. So if intervals equals null, or intervals.length. Wait, am I recording? Yeah. Or intervals.length equals 0. Then just return 0. There are no meetings scheduled. So easy. All right. And then now we're going to get into like the bulk of our code. So we're going to say, like we said, it was easier to have these sorted based on the meeting that was happening the earliest, right? Bill's meeting happened first. Howard's meeting happened next. Because, there's no order to things. I'm not like Adam's not gonna skip me and go find a room because my meeting starts before his. So it makes sense to have these sorted so that we can compare them easier. So first, what we're gonna do is sort the meeting intervals. So we're gonna say arrays.sort, and we're gonna say intervals. We're gonna pass in intervals, and then we're also gonna pass in a new comparator. So new comparator, and it's gonna be like comparing these individual array intervals in our main intervals array. So new comparator int, and then we'll just write our compare function. So we'll say public int compare. We'll take in our 2 arrays as parameters. So this is just a basic like compare function with a comparator. So we'll say return. And what we want to sort these initially by the start time, right? Like I said, we want to put the earliest meeting first, and the next earliest meeting, the next earliest meeting. So we'll say return A at the start time, which is the 0th index, minus B at the start time. So if you look here, intervals.I represented each interval had a start at the 0th index and an ending at the 0th index. So we just want to sort it first by the start time to make sure we have our meetings in order. So that's why we did A at 0 minus B at 0. So there's that. And then now we can like get into our code again. So let's see, how can I explain this? So what do we do here? So what we're gonna use for this is we're gonna use a priority queue to keep track of the ending times to sort. So we're gonna sort the ending times in our priority queue so that each new person that comes can just check our ending time and get the ending time and check, if their meeting time ends before ours starts. So it's a little hard to explain, but a priority queue is perfect for this because we can check the current meeting that's going on and check its ending time, and we'll have that at the top of our queue. So we'll always have access to the meeting that ends the earliest. Okay, so we'll say priority queue int an array of ints. I'll call it the scheduler because this is where all the meetings are scheduled, or all the meeting rooms will be scheduled. So priority queue int scheduler equals new priority queue. Passing it. Well, you don't have to pass it in here, but just to make it clear, I'm going to pass it in there. And then in here, we need a new comparator. And, all right. So in here, we're going to have another compare function, public int compare. Public int compare. Oh, okay. So it's going to do the same thing, int b. But this time we're comparing based on what time the meeting ends, okay? We want the meeting time that ends the earliest on top so that we can compare our other meeting times to it, if that makes sense. So our priority queue will initially have our first meeting, whatever our first meeting was, our earliest meeting. And then from there, it's going to compare the end time. And then, if we're adding our new meeting to our priority queue, it will be sorted when we're removing things. It's kind of hard to explain, but hopefully it will make sense when we start like adding things. So public int compare. So we'll just say return, since we're comparing by the end times, which is at index 1, we will return a at 1 minus b at 1. All right. So that should do it for our priority queue setup. So we sorted our arrays by start time first, and then we now are sorting them into our priority queue. We'll play by their ending times, so that every new meeting that's coming through, we can ask, hey scheduler, does this meeting end before mine starts, or does it end after my meeting starts? Basically the same thing I was illustrating here. Like Adam said, Hawa, does your meeting end before mine starts? Okay, I can use you. But in the case of Bill's like, no, my meeting ends at 30, yours starts at 15. You can't use my room, so find a new room. So that's kind of what we're gonna have to simulate here by using our priority queue. So yeah, that's the whole purpose. So now we're gonna say, obviously right now our priority queue is empty, but we know that if we got to this point, if we got past this check, we know we at least have one meeting in our intervals. So we'll say, let's add the first meeting to our priority queue. And remember, since we sorted it, that will be the earliest meeting that's occurring that day. So we'll say scheduler.add. I always spell this wrong. Scheduler. I don't even know how to spell schedule. Oh my god, school's about to start and I don't know how to spell schedule. Okay, anyway, so scheduler.add, we're gonna add our first meeting because obviously we know we at least have one meeting scheduled today. Bill's meeting is the first meeting that's scheduled for the day, so let's add it into our priority queue so that every other meeting that's scheduled, we can ask Bill if he has a free space. So we'll say scheduler.add. Let's see, scheduler.add. Wait, what are we adding? Okay, we're adding I got lost. We're adding the first meeting, so intervals at 0. That will represent our first meeting. Intervals at 0. That will represent our first meeting. So now what we can do is traverse through the rest of our meetings. So right now we have Bill's meeting in the queue. We don't need to worry about his for now. But now what we need to do, we need to find meeting spots for me, Hawa, and we need to find a meeting spot for Adam right here. So me and Adam both need to find meeting rooms. We don't know what to do. Our meeting is coming up. So now what we do to simulate the act of us knocking door to door, asking what time does your meeting end? Do I need a new room or can I reuse your room? To simulate that, we're gonna traverse through the intervals. So we're gonna traverse through the meetings. Basically, that simulates us basically kind of going door to door. So I equals 1. I is less than intervals.length. I plus plus, and this is when we start knocking on the doors. So what we're first gonna do is say, we're gonna have a variable to represent the meeting that's going on right now. So Bill's meeting. So we're gonna say ongoing meeting equals, and that's gonna equal the value in our priority queue. So we're gonna say ongoing meeting equals our priority queue or scheduler. We call it a scheduler dot pull. So that will remove that value to us and return it to us. So we'll say that's the ongoing meeting that's going on right now. Before this, I'm gonna say the next. Actually, I'll prefer to say the upcoming meeting after this, just for like chronological ordering. So I'll say an array of ints. That's what I'm gonna get. My upcoming meeting is gonna equal our intervals at I, because remember we're basically checking who's next in line, like who's. So here in the case of this, before all this stuff, I was in line first, Adam was in line second. So first we said, okay, who's next in line? Hawa is next in line. That's basically what the for loop is simulating here. Okay, so Hawa is next in line. Hawa has her upcoming meeting. That's at intervals at I. And then if we were to go through this loop again, it would say, okay, now Adam is next in line. His meeting is coming up intervals at 2. So intervals at I. So I hope this is making sense. I'm trying to make this as like visual as possible. So in upcoming meeting equals intervals at I. So now what do we want to check? We want to check if the ongoing meeting's time is going to end before our meeting starts. So like here, I asked Bill, does your meeting end before mine starts? That way I can reuse your room. So how can we stimulate the act of asking if the ongoing meeting ends before our start? So we're going to say if. Actually, first we're going to check if it doesn't end. So we're going to check the case that it ended at 30 and mine ended at 10. It ended at 30 and mine started at 5, so I couldn't use Bill's room. So that's what we're going to simulate. So basically the opposite of what I was saying. So we're going to say if the ongoing meeting's time ends after my meeting starts, then let's do something. So I'm going to say if the ongoing meeting at the end time. So remember, the end time is the first index. That's where the meeting ends. That's what represents the end time of the interval. So if the ongoing meeting ends, so if the ongoing meeting at index 1, if it's greater than, so if it ends after my upcoming meeting start time, so my upcoming meeting at index 0, if it ends after my upcoming meeting starts, then I know this is a conflict. There's no way my upcoming meeting can use this room, right? There was no way I could use Bill Gates' room because my meeting started at 5 and Bill Gates' meeting ended at 30. So I had to go find my own room, right? So, okay, so now that we know what we're trying to say here, how can we simulate the act of getting my own room? So we'll say, okay, if the ongoing meetings the ongoing meetings end time is later than my upcoming meeting start time, then I need two separate meeting rooms. So how can we simulate having 2 separate meeting rooms? So what we're gonna do is add our ongoing meeting back to our heap. So we're gonna add both of these meetings to our heap to simulate the fact that we are going to be getting 2 separate rooms. So we'll say scheduler.add. So add to our scheduler this meeting, which will take 1 meeting room, and the upcoming meeting, which will take another meeting room. So basically, the scheduler queue is simulating how many meeting rooms we're using. So scheduler.add ongoing meeting, and then scheduler.add our upcoming meeting, right? We know we couldn't reuse Bill Gates' room, so we need to also add our room now and our meeting time. So now we get to our else statement. And what is our else statement going to represent? So we're going to assume here that a meeting, for example, we're going to assume that some meeting, let me clear this, some meeting, like if we had 2 meetings like 0 to 4, and we had another meeting that starts at 4 to 6, we're going to assume that these 4 here, we're going to assume they're perfectly fine. We're going to assume that we can reuse the same room. So we're going to say, okay, Bill's meeting ends at 4, mine starts at 4. Let's just reuse the same room. You know, we'll be in and out. We're switching. We're going to reuse the same room. So in this case, I'm just going to assume that. So we're going to say else if that's the case, or if the the ongoing meeting, if it ends before my meeting starts, so my meeting starts at 6, the ongoing meeting ends at 3, in both these cases, I know I can reuse the room. So how do we know? How can we simulate reusing the room? So simulate reusing the room. And here I'll say booking a new room. So we need to be able to simulate reusing the room. So the way to do this is, now I will go back to my picture here. Okay, this is very, very messy, but I'm going to try to explain. So remember I said to keep in mind that these will come in handy. The actual room itself. So we had room A, we had room B. So now I'm saying Adam and Hawa are going to use the same room. I'm going to reuse room B. So in the beginning, when Hawa was the only one using room B was occupied from 5 p.m. to 10 p.m., right? We don't care who was in the meeting. We don't care whose meeting it was. We just care how long was room B occupied, because we need to know when room B will free up. So room B was occupied from 5 to 10 p.m., but then Adam is waiting in line to use room B. So how long is room B going to be occupied now? If somebody else came with a new meeting, say they came with a new meeting and they had a meeting from 10 to 20, and they wanted to come use my room, I'll say, no, Adam is next in line from 15 to 20, so you can't use my room, right? This is just an example. Don't get confused by this. It's just saying, this guy came and asked me to use my room. He's like, oh, your meeting ends at 10, my meeting starts at 10, perfect, I can use your room. And I'm like, no, Adam is next in line. He'll be in a meeting from 15 to 20 p.m. And then this guy will say, well, then why didn't you update how long our room will be occupied? How long room B would be occupied, so I would know not to ask you, or I would know to find another room. So here, if Adam is next in line to use room B, then room B's occupation time needs to change from 5 all the way to 20, because that's how long the room will be occupied with meetings. There are 2 meetings going on. We don't really care actually how many meetings are going to be happening in room B, but what we care about is, because we're reusing the room is not occupied from 5 to 10 now, it's occupied from 5 to 20. So people need to know when the room will free up, what time the room will be occupied, when it will free up. So this is when we kind of simulate reusing the room. We need to basically extend the time that the room will be occupied. And how can we show that using code? So we'll say else. Okay, how can I now I have to think about this really fast. Let's see. Okay, so else your okay, I need to clear. Okay, let me clear this. Let me show you here. So right now Hawa is in. So this is meeting room B. Okay, right now Hawa is in a meeting from 5 to 10. Adam is next in line. Adam has a meeting in room B. Remember, we're in room B right now. Adam has a meeting from 15 to 20, and we said that we need to update how long room B will be occupied. So room B is going to be occupied from 5 to 20, right? Because we have Hawa's meeting till 10 and then Adam's meeting till 20. We don't care whose meetings we have. We just care that this room is going to be occupied up to 20. So we want to say, okay, the ongoing meeting, if this is the ongoing meeting, so remember we had the ongoing meeting variable. So if Hawa's meeting is ongoing, all I want to do to represent or to simulate the fact that this room B will be occupied until 20 p.m., how about I just extend this? I take this and I extend it. I just extend the time to be 5 to 20. It's not necessarily saying that Hawa's meeting is going to go till 20, but it's going to represent that our meeting B will be occupied from 5 to 20. So how about I just take the time that Adam's meeting ends and I replace the time Hawa's meeting ends, just for simplicity's sake, to show that this room is occupied from 5 to 20. So in this case, all we have to do is say, okay, take the ongoing meeting, like I just showed. Take Hawa's meeting, the ongoing meeting, right here, the ongoing meeting. This is the ongoing meeting, Hawa's meeting. We know right now it ends at 10, but since Adam's going to reuse this room after me, say take the ongoing meeting's end time, so at index 1, that's the end time, and update it to be the end time of Adam's meeting, the end time of the upcoming meeting. So equals upcoming meeting at its end time. Okay, so I really hope this makes sense. We're not really caring about, oh, how many different meetings are there, how can we represent that there's two people reusing the same room. We care about the time that the room will be occupied. The time that the room will be occupied. So if I know Howard's gonna use the room from 5 to 10, Adam's gonna use the room from 15 to 20. I know that this room is occupied from 5 to 20, and that's literally all it is. So we're gonna update. Okay, we'll say, let's just say that Howard's meeting or whatever ongoing meeting, we'll just say it will go. It will go until the upcoming meeting's end time. So we'll show that room B is occupied from 5 to 20. Oh my god, that was a lot of talking. I really hope that made sense. I don't know what better way to explain this, but since, just think about it. Since somebody is waiting in line for this room, we want to update how long this specific room will be occupied so that somebody here doesn't come and try to take the room when there's already other people in line for the room. So I'm hoping that makes sense. Um yeah. So, and then after this, we need to add that same room back to our scheduler. So we'll say, okay, we've resolved it now. We've figured out if I'm gonna need to book a room. If I'm gonna need to book a new room, we figured out if I can reuse the room. Now that I figured out if I can reuse the room, let's just add that same meeting that was already there, but with the extended time to show that that room will be occupied until a certain time. So that's what this represents. And then we add it back to our scheduler, and this loop will continue until it checks all the meetings that are upcoming. And then after this room is finished, all we have to do is return scheduler. Scheduler? I know I'm gonna have a typo for scheduler somewhere in this. But yeah, that's literally about it. I hope that makes sense. I hope that makes sense. Let me just check this. Anyway, I'll just run it and see if I have line 32. Okay. Judging. Do I have like an infinite for loop somewhere? I don't know why it's taking so long to judge. Okay, let's see. Oh, I'm sorry. So scheduler, remember, is our min heap, and here scheduler is basically representing the amount of meeting rooms we'll need. So we'll just need scheduler.size, scheduler.size, because that's okay. That's the amount of meeting rooms we'll need. Okay, sorry about that. Okay, so that's accepted. I was gonna say one more thing. Okay, time complexity. There are two main things that are taking time complexity in this algorithm that we have. So firstly, the sorting of the arrays takes O of n log n time to sort, considering the array consists of n elements. And then the other operation that's taking a lot of time is our min heap, which is our priority queue here. The reason it is taking time is because in the worst case, we'll need to add all n meetings to our priority queue because they'll all be conflicted, and we'll need all n separate meeting rooms for these meetings. So that's the worst case. But like in any case, we have n add operations. So if you can see here, in any case, we had to add back the ongoing meeting. And in the worst case, we'll also have n like remove minimum operations or extract the min from the priority queue. We'll need to take away n from the priority queue. So n elements, and that's the the extract min operation for the on a heap takes O of log n time. And because we're doing this for, in worst case, n elements, it will take O of n log n time. And then space complexity is just O of when O of n, because we're constructing the min heap and then it contains all n elements, and that's it can contain all n elements, I should say. And then that's it for the time complexity. So let's just see if this works. Alright, so it works, and I hope that explanation made sense. It was kind of fun to make, so if nobody watches this, I'll just watch it and laugh on my free time. But anyway, thanks for watching. See you guys next time.